Good afternoon, everybody. My name is Graham Hamill. I'm Senior Vice Provost for Faculty Affairs, and I'm Dean of the Graduate School here at UB. And it is my immense pleasure to welcome you to UB's 10th annual 3-minute thesis competition, a campus-wide competition that asks advanced doctoral students to present their research to a panel of non-specialists in 3 minutes or less. And now I'd like to invite President Satish Tripathi to come to the stage and offer some welcoming remarks.
Good afternoon, everyone, and thank you, Graham, for the introduction. I'm really delighted to welcome you to this year's 3-minute thesis competition. Today, we celebrate a significant milestone. It is actually 10th year of 3MT at UB. This is how it's called, 3MT, right? For a decade, this competition has showcased the extraordinary talent, curiosity, and determination of our doctoral students. At the same time, it has underscored the importance and the power of clear, compelling research communication. I would like to extend my sincere thanks to our distinguished panel of judges. I'm especially pleased to note that this year, each of our judges is a former 3MT finalist. To our judges, your presence here today speaks to the lasting impact of this competition and the strength of our UB community. You understand firsthand the challenge our finalists face, and you represent the remarkable trajectories that began on this stage. And now to our finalists, congratulations. Reaching this stage of such a rigorous and competitive process is an exceptional accomplishment. Our doctoral programs are a central part of UB mission as a premier public research university, and the 3-minute thesis competition embodies that mission. While walking here from my office, I was thinking many decades ago when I was doing my own PhD dissertation, if I were asked to give it 3MT, would I be able to do it? I had a lot of time to think, about 8-minute walk. So I thought, let me tell you, it's going to take a little less than 3 minutes, but about my thesis. And this is almost many decades ago, 4 or 5, you can count. So in those days, the computers were large. I'm a computer scientist. The computers were large computers. They were called time-shared with hundreds of people using the same machine. The machines did not have enough computing power or enough memory to host the programs. So there were a lot of secondary devices. Think about clouds now. And you had to think about how do you optimize the usage of the machine. At the same time, how do you minimize the response time of all those hundreds of jobs that are simultaneously computing. You didn't have enough computing power to model them and to compute it, your models. So my thesis was really to look at policies to schedule some of those jobs on the machines and evaluate them before really giving it to the policy implementers. It involves what is known as queuing theory. It involves what is known as analytical models. And I was able to not solve those models precisely, so it involved approximation. This is 2-minute presentation. I don't know if I was successful or not. But at the end of the time, it got me 3 papers, so that was really what. and really, it is still applicable in the sense that we call this performance evaluation, queuing modeling of large computer systems. And as I look at the research now, some of those thinking, not necessarily the models, are still applicable in large cloud computing environment. Because you still have, anytime you use resources, you share resources with multiple people, there are resource allocation problems, and there are congestions. And those problems don't go away, no matter how much computing power you have. So that's really what I did. But I really look ahead to your presentations. I might have to leave in the middle, but I'll try to attend as much as you can. Congratulations, and thank you.
Thank you, President Tripathi, and I also just want to say thank you for your ongoing support of this event. I don't know that you've attended every event, but I think you've attended almost every event, and your support of doctoral education more broadly has been really meaningful, so thank you for that. The 3-minute thesis competition was founded at the University of Queensland in Australia in 2008. The competition is globally recognized and held in over 900 universities in over 85 countries. This very exciting campus-wide competition challenges our advanced doctoral students to present a compelling and concise overview of their research to a panel of non-specialists in 3 minutes or less. From our first presenters to today's communicators, this competition has helped shape a generation of researchers into storytellers, leaders, and change makers. Over the past 10 years, we've had more than 100 students take the stage, dozens of awards earned, and ideas spoken here have reached new audiences, and countless others have participated in the competition itself before this final stage. To all the finalists, congratulations on reaching this point in the competition. It's an impressive achievement and a testament to your hard work and to your dedication. Preparation for 3MT competition began here at UB in the fall with our preliminary round. This initial round brought fierce competition, leading to our 10 finalists today. After being selected, our finalists went through various workshops and training to help them hone their abilities, including a digital portrait workshop. These digital portraits are on the 3MT website and along the hallway outside this room. They give a beautiful representation of the finalists and the research presented here today. Thanks to the CoLab, UB School of Management, and University Communications for supporting these workshops. Today's event is co-hosted by the Graduate School and the Startup and Innovation Co-Laboratory, or CoLab. Thanks to all the staff who worked to host this event, and thank you to our campus partners for your work in promoting this event through our university-wide campaign. I especially want to commend all the graduate students who participated. There's been remarkably positive responses to this event from students and faculty who recognize the importance of doctoral education and of communicating doctoral education to the university's research mission. In addition, I'd like to thank Sandy Flash and Sue Adenolfi for starting the competition here at UB 10 years ago. I'd like to welcome our audience from campus and all over the globe who are watching today over our live stream. You can find the bios of our MC, judges, and today's contestants on the 3MT website, which you can find right there. I know you're eager for the competition to start, so I'd like now to introduce our MC, Dr. Ben Ryan, a neuroscientist, science communicator, author, and graduate of UB with a PhD in neuroscience. He is also the winner of the 2020 3MT competition, which was actually the last event that was held in person on UB before we shut down for COVID. Ben will introduce the judges and participants of today's competition.
How we doing, everyone? It is an honor to be emceeing the 10th anniversary of this event. I am a neuroscientist by training, but now I spend most of my time working on science communication, and it actually started with the 3-minute thesis in 2020. I presented right here in this room, as Graham noted, to an empty room, actually, because it was March 13th, 2020, like the day COVID happened. So I won first place, and it was extremely empowering for not only myself, but the other students as well. And I think that's incredibly important. Maybe the most important part of science is the communication and dissemination of the research. It's really important that it doesn't stay within the walls of academia, and I think that I just want to take a moment to applaud not only the finalists, but also everyone who competed in the preliminary competition for their courage to try this, and I guarantee that your career will be better off for it. So thank you for embracing this challenge. So today, the PhD students presenting will be judged on 3 categories, or 3 main things. Number 1, their communication style. Was the research communicated in language appropriate to a non-specialist audience? And was the one static slide allowed during the presentation clear and helpful in enhancing the presentation? Number 2, comprehension. Did they help you, the audience, understand the research? And number 3, were they engaging? Did they leave you wanting to know more? We are honored today to have an esteemed panel of judges whose evaluations will determine our first, second, and third place winners. Our panel of judges comprises community leaders from various industries, including orthopedics, entrepreneurship, engineering, education, and research. Our judges are experienced professionals who have mastered communicating their work to broad audiences, and we're all prior competitors in the 3-minute thesis, and recognize the development of this critical skill in graduate students and the potential global impact of doctoral research. Please help me give a warm welcome to Haley Chiswick, Research Assistant Professor in Orthopedics at the University of Buffalo and winner of the 2023 competition. Antonella Di Giulio, pianist, scholar, and interdisciplinary entrepreneur and finalist of the 2017 competition. Danielle Lewis, postdoctoral associate in the Department of Engineering Education here at UB, and third place winner in 2022. Phil Odencourt, assistant professor at Stevens Institute of Technology and winner of the 2018 competition. And Phil Schneider, senior director of research and development at ACV and winner of the 2017 competition. Ladies and gentlemen, please remember that everyone watching in person today is also a judge, as your votes will help determine the People's Choice Award winner. So keep that in mind. So, on to the competition. Our finalists today exemplify the very highest standard of excellence at UB. I will introduce each finalist to you, and as I am doing so, they'll come up on stage and prepare to present. I will share a fun fact or two about each of them, and they are very impressive people. I'll finish my introduction by saying ready, set, pitch. The presenter can then take a second to ready themselves, and when they start speaking their first word, their slide will appear on the screen, and the timer facing them, they can see one behind this plant, and facing you in front of that plant will start. And I believe if they go over time, they will be eliminated. So 3 minutes is incredibly important. So let me start by introducing our first presenter, who is Wenxi Wu from the Department of Pharmaceutical Sciences. Presentation is called Corticosteroids, the Storm Stopper, and kicking off the round of impressive decorations. She's the first in her family born in the U.S., the first to go to college, and a McNair Scholar, which is extremely impressive. So, Wenxi, you deserve it. Okay, ready, set, pitch.
I want you to think of a villain in your head. Any villain you want. Got it? Now, I can't read your mind, but I'm confident you didn't imagine your own immune system as the villain. But in cytokine release storm, or CRS, the hero of your body becomes the villain. The immune system that's supposed to protect us goes out of control and starts attacking us. And now you may wonder, why is this villain in our bodies in the first place? And it can be caused by different reasons, such as cancer treatment and something we all know about, COVID. I want you to imagine your body as a city. Each organ is a building. CRS would set these buildings on fire. And the worst part is that it doesn't set one building on fire at once. It sets this whole city on fire. And if the fire's not taken care of, then the whole city will burn down and we'll die. But no need to worry, because supercorticosteroid is here to save the city. Corticosteroid is a powerful anti-inflammatory drug. Get it? Because your body is in flames and its job is to take out the flames. But it is not to replace the immune system, but to calm down the storm, to bring it back under control. But here's the problem. Doctors usually test our blood and assume that CRS has been destroyed. But what if there's still fire raging inside these buildings or our organs? That's where my research comes in. I use rats to look inside these organs. So meet our sidekick, Dr. Rat. Dr. Rat has X-ray vision that can sneak inside these buildings to find where the fires are still raging. Since we can't see what's happening inside the human body, using a rat model helps us to understand what's happening to our organs. And Dr. Rat allows me to build a city map for rats. And this city map contains information about how strong and how fast our superhero corticosteroid is, and even which building or organ this hero goes to and how long it stays. Then, with the use of math, science, and coding, I can create a new city map for a city we all know about. Humans. We can finally understand what's happening to our bodies when CRS attacks. And not just that, how strong we need our superhero corticosteroid to be to beat this villain. Because this is not science fiction. This is real life. And one day, CRS might attack you or me, whether that is during cancer treatment or another pandemic. My research is to make sure that when this villain, CRS, shows up, our superhero, corticosteroid, is ready to save us. Thank you.
Amazing. I'm going to give the judges a minute here to do their work. In this interlude, I think it's worth noting that, there's so much to this challenge. Not only finding the way to condense 4 to 5 to 6 to 7 years of research into 3 minutes, but also presenting it, also memorizing it. You have to come in here and you have to beat the clock. So it's a lot. It's a very demanding challenge, and so all the applause for our competitors is very much deserved. All right, judges, are we doing good? All right, I see a couple thumbs up. Okay. Our next presenter will be Gavin Rafleur, coming from the Department of Communication. The presentation title is Counselor GPT, Understanding Users of Generative AI for Therapy. Gavin's fun fact is that he has been a practicing therapist since 2019, and this is amazing. His wife and him personally mined the diamond for her engagement ring and the diamond used in her necklace at their wedding. Amazing. And a beautiful thing. All right, Gavin, are you ready?
I am.
That doesn't count as his first words. Ready, set, pitch.
Since the events of the COVID-19 pandemic, we have seen record-setting rates of anxiety, depression, loneliness, and other mental health concerns. Unfortunately, this is happening at the same time that we're experiencing a shortage of mental health therapists. This has left us in a crisis of mental health, which has been defined by long wait lists, high session costs, and a lot of people whose needs are going unmet. It should come as no surprise then, in the face of these systemic barriers, that people turn to artificial intelligence to meet their mental health needs. As many as 1 in 5 US adults have tried AI for therapy, and according to the Harvard Business Review, therapy was the #1 most reported use of chatbots in 2025. People have turned AI into their confidant for their most private and sensitive concerns. Academia has largely taken to trying to answer the question of whether or not AI can be a good therapist. But I'm worried that this is not the right approach. I myself am a licensed mental health therapist, and I practice what's called person-centered therapy. Across all the literature so far, one question has gone unasked. Who are the people who are turning to AI in the first place? Much like how I, as a therapist, and all other therapists want to understand you, the person that walks through the doors of our practice, I now want to understand who are the people who will rely on AI for their mental health. This is the question that my dissertation contends with, and I began this journey with a content analysis of the online forum Therapy GPT, a place where people have gone to share their advice and experiences with their use of AI for mental health. And already we've yielded some important findings. We found some potential drivers of this behavior, things like a fear of judgment, a belief that AI are more reliable and trustworthy than humans, and unfortunately, a lot of people having a history of therapists failing them before. These factors have now culminated in an experiment ongoing where we're trying to see if they can be good predictors of whether or not somebody from the general public is likely to turn to AI when they too face those systemic barriers that I mentioned. The findings of this experiment could help us to target future therapeutic AI interventions, but also ground future scientific work in an understanding of the human being at the keyboard. We all want our healthcare landscape to accommodate AI in a way that benefits people. We cannot just start with an understanding of the AI. No. we need to understand the human beings who are going to turn to it. Thank you.
Fantastic. Another thing I love about the 3-minute thesis competition and the event is that you get to learn about the amazing work that's happening right here at UB. And it's incredible because it's not only so impactful, but it spans such a wide range of disciplines and answers really important global questions. Judges? Good? All right. Our next presenter is Hope Niardi, coming from the Department of Pharmacology and Toxicology. Her presentation is One Life, One Light, Get Your Injured Brain Back in the Game. Continuing the impressive history of these competitors, Hope performed in 2 NFL stadiums in high school marching band and was a Division III collegiate field hockey player, multi-talented. All right.
Yep.
Are you ready?
Yep.
Ready, set, pitch.
Let's play a game. Don't worry, it is one that we are all capable of playing and have access to here in the Center for Arts and even on YouTube. It's called Hope Says, so do what Hope says. Hope says when I raise my hand, clap. Hope says pat your head and chin at the same time. Hope says stop. Now let's pause our game. You all played that game really well, but the 42 million people around the world who suffer a minor brain injury every year may struggle playing. They might forget the rules, they may be experiencing fatigue, physical pain, or have trouble focusing, which can make them take longer to clap, or struggle multitasking with something even as simple as patting their head and chin at the same time. So how do we get them back in the game right after their injury? Like most injuries, you just need to recover. But unfortunately, there is no definitive time frame for minor brain injury recovery. It can take 2 weeks, it can take several months. These inconsistent recovery patterns make the difference in pausing or stopping the game entirely, and has ultimately exposed the main problem we are currently facing in this research field. We do not have a single brain injury recovery approach that can be applied to anyone around the world in terms of capability and accessibility. Knowing this is a worldwide problem is why I do this research, so no one in the future has to face the inconsistencies of recovery patterns and approaches that not only myself, but millions of others have already faced. So how do I do it? I am researching red light laser therapy on people who have recently suffered a minor brain injury. I use my portable handheld laser device like a magic wand and wave it across 8 specific areas on your head. This direct contact onto your head allows the light to travel into your brain and is absorbed by specific messengers within your brain that help you heal. To track your progress of recovery, I ask you questions about the issues you're experiencing that relate to your injury. While you're completing thinking activities, I watch to see how quickly you complete them, the strategies you use to complete them, and how much content you remember from them. I even look at your brain activity in real time with a sensor net made of sponges that rests gently on your head, and by assessing the contents of your spit. So far, 8 people who have already let this light shine have expressed they experience less fatigue, physical pain, and showed an improvement in focusing and memory reflected from their thinking activities and real-time brain monitoring. They have even shown us something more important. Everyone had the capability and accessibility to receive this light therapy because this device is portable and all they had to do was sit in a chair. We only get to play our game of life once. So it is time that we not just add years to our life, but life to our years. So let's get our brains back in the game. Speaking of that, ready to resume our little game from earlier? Hope says give me a thumbs up for a new light on brain health. Thank you.
All right, I'll give the judges a moment. The other thing that's awesome about this competition, sorry, I'm just gonna keep hyping up the 3-minute thesis, I love it. But I wanna say, by show of hands, who has already learned something? Yeah, everyone's hand is up. Amazing. And this is an important note. Science communication is a 2-way process, right? It's reciprocal dialogue, and it takes 2 to tango. So thank you for showing up here today and opening your ears and brain. Judges good? All right, our next presenter is Emily Alden Black, coming from the Department of Communication. Her presentation title is It Wasn't a Stampede, How We Talk About Crowd Disasters and Why It Matters. My fun fact, I had a hard time choosing one fun fact for Emily, but I'm just gonna read this as it sits. I've been wearing a denim jacket with safety pin wings almost every day for a decade now. At one point in college, I was identified in conversation as Emily, you know, the one with the jacket. And I believe the jacket is on your chair over there. Is that right? Yep. All right, awesome. All right, Emily. Ready, set, pitch.
Crowd crush. Have you heard of it? I don't blame you if you haven't. It's not exactly a commonly known type of disaster. You might know it by another name. Crowd surge, crowd collapse, mass panic, or human stampede. I hate that word, stampede. And I'll tell you why. The words that we use to describe disasters, they matter. Picture in your head right now, actually imagine, what does a stampede look like? I'm guessing for at least a few of you, you're imagining something out of a country western film. Herds of panicked cattle trampling over the land, destroying anything in their wake. Stampede brings to mind images of livestock, of animals, of panicked crowds trampling each other in a selfish and irrational rush. That is not what a crowd crush looks like. Crowd crushes are slow and inexorable things. At the kind of density we're talking about here, the kind that kills, a single person in that crowd, no matter how desperate, no matter how selfish, has as much control over where that crowd goes and what it does as a drop of water does in a tsunami. These people are not to blame. And yet, that is what the word stampede does. It blames the crowd, and in doing so, it blames the victims. In doing so, it exonerates the buildings, the systems and the structures that actually need to be changed to prevent this kind of thing from happening again. To steal a line from Kipling, with stampede, the blame for loss or murder is laid upon the man. Not on the stuff, the man. Or is it? Because here's the thing. As much as this argument logically makes sense, as much as it has been spread in newspapers, in journal articles, the idea that stampede changes how we think about crowd disasters has not actually been empirically tested. That is what I'm doing with my dissertation. If it turns out that the results of my experiment show that stampede does not have an effect, that exposing participants to stampede language instead of crowd crush and news coverage does not make them blame the victim, great. A lot of very talented researchers can move on to more productive pastures. But if it turns out that stampede does have an effect, that it does make audiences blame not the stuff, but the man, then this is proof. This is evidence that we can hold up when we ask people, when we tell them, please, the words you use matter. It wasn't a stampede, it was a crush. Thank you.
Judges, I'm going to give you a second here. Emily, I hope to see the jacket, by the way, in the waiting area. All right. Our next presenter is Yuya Yamamoto from the Department of Learning and Instruction. The presentation title is Who Owns Teachers' Learning? Reimagining Teacher Professional Growth Through Co-Design. Yuya came from Japan, was born in Japan.
Yes.
And is a current Fulbright Scholar from Japan and previously worked as an English foreign language teacher in Japan for over 6 years. Awesome. All right. Ready, set, pitch.
Think back on your school days by a show of hands. How many of you here had a teacher who changed your life? Thank you. To cultivate more teachers like that, we must help teachers keep learning. As a way to support their learning, designing effective training programs is essential. But here's the problem. When I used to teach English in Japan, I often wished I had a training that better met my professional needs. Yet, existing research also shows many training programs are usually designed without teacher involvement. In other words, traditional training models can be like leading a horse to water. That is, You can bring teachers to predetermined training sessions, but they won't be really engaged unless it connects with their classroom realities and professional aims. As a result, teachers may not bring what they've learned to their classroom teaching. So that's where my study comes in. I conducted design research to develop personalized teacher training through co-design with teachers. As a teacher educator, I closely work with 3 English teachers over 2 months in one high school in Japan. Together, we try something different and innovative. Instead of traditional top-down training, we co-designed teacher learning activities with frequent adjustments. In our weekly workshops, for example, we discussed and chose topics together, and based on their expressed needs, I shared classroom activities aimed at promoting students' communication skills. I also built in many opportunities for peer collaboration, so teachers could learn from each other while providing personalized support through one-on-one meetings and classroom coaching. The impact was clear. Teachers deepened their understanding of teaching methods, which they were eager to explore further. And most importantly, they stepped out of their comfort zones and tried new classroom activities selected from our workshops. This is crucial because their participation was voluntary, and I never required them to implement the activities. Yet, they chose to try. That shows the real potential of co-design training. To conclude, when teachers help shape their own training, assisted by peer collaboration and personalized support, authentic professional growth occurs. If we want more teachers to inspire the next generations, just as many of you are inspired, we must support their learning by designing teacher training not only for them, but also with them. Thank you.
Thank you, Yuya. Our next presenter is Teresa Rin from the Department of Oral Biology. The title of her presentation is Spit Happens, Restoring Salivary Gland Function. Some fun facts about Teresa. She has played ultimate frisbee competitively and went fishing during a pink salmon run in Alaska. That sounds, did you catch some salmon?
I did,
Nice.
yep.
That
And I got
sounds-
a picture holding it, it's slimy.
Sweet. Sounds like fun. All right, Teresa. Ready, set, pitch.
I want to tell you about a situation. The person you see up on the screen had cancer, and in order to get rid of the cancer, she underwent radiation therapy. Now, that same therapy that helped treat the cancer is the same therapy that has now permanently damaged her salivary glands, the organ that produces your saliva. Damage to your glands is not just limited to this situation, however. It can also be caused by other diseases or natural aging. The person you see next to her lives within your glands and is trying to fix the damage that has happened. But more on him later. I want to go back to your saliva for a second because it's not something you think about every day until you don't have it anymore. Without saliva to moisten your mouth, you can't eat, talk, or chew properly. Without the protection of saliva, you have painful fissures that form on your tongue and increased infections that happen in your mouth. Life becomes quite uncomfortable, and patients are left to live in constant discomfort because we have no cure. We do not know enough about your salivary glands in order to fully restore their saliva-producing capabilities. However, that is where my research comes in, which is aimed at identifying those important components that maintain both function and structure of your glands. Now, this organ is made out of building blocks called cells, and I want you to imagine that each cell is a mini factory where you have managers and the assembly line. However, there are hundreds of these managers, but I can predict which ones are important by using a fancy computational algorithm, and then I can physically remove them from that factory. Through this process, I've identified a manager named XBP1, which I have spent the past 5 years and a multitude of experiments showing that without this manager, those factories stop working. Cells die, the structure of the gland changes, and most importantly, there's less saliva being produced. My hope is that in the long term, this manager remains a part of the conversation as we look towards long-term therapeutic options for people who suffer from salivary gland dysfunction. Because at the end of the day, these patients, especially the ones who have already battled cancer, do not deserve to spend the rest of their life in discomfort. Thank you.
Thank you, Teresa. Our next presenter is Chris Romeo from the Department of Engineering Education. His presentation is titled "The Trouble with Troubleshooting: Investigating Undergraduate Engineering Students' Difficulties with Troubleshooting." For his fun fact, he gave me a lot. He gave me 8 here. And
I'll let you pick.
also noted, I feel like my fun facts suck, but they don't. I think probably the best one is that he once met Billy Joel in a random Dunkin' Donuts in New York.
Sure did. Turns out he's just a regular guy who also needs coffee.
Yeah.
Like, that's, yeah,
Celebrities need coffee too.
they do.
All right, Chris. Ready, set, pitch.
Okay, show of hands. Thank you. How many of you have ever had to troubleshoot issues with your printer before and gotten so frustrated you felt like doing that to it? Okay, yeah, I thought so, right? We've all been there before. I can tell you I've had to play tech support for my dad at home about 1,000 times fixing issues with the printer. Shout out to him for the inspiration, by the way. Point is, we all have to troubleshoot things as part of everyday life, right? It's just a crucial skill you have to succeed in the world. Well, unfortunately, I can tell you that undergraduate engineering students do not possess this skill as much as we would hope. Research has shown that troubleshooting is a big problem for students. They often can't troubleshoot technical issues that just naturally come up while they're doing important class activities like lab experiments or course projects. So why is this a problem? Well, their inability to troubleshoot can make them feel like this, sure, but more importantly, it prevents them from completing those activities, which hinders their learning and prevents them from mastering course concepts, right? Even worse, what happens when these students become practicing engineers working on real problems, where the stakes are much higher and the consequences for not being able to fix things are much worse than just getting a bad grade on your assignment? In the real world, you can't just give up and ask the TA to fix it for you. So, how do we help engineering students become better troubleshooters? Well, that's what I'm trying to figure out. Specifically, my research tries to understand why engineering students struggle so much with troubleshooting in class context so that we can come up with ways to help them get better at it. To do this, I'm going to recruit a bunch of electrical engineering students. I'm going to give them a broken circuit to troubleshoot, and then I'll try and identify the major challenges they run into while they're trying to fix it and where they get stuck the most while they're solving the problem. I'll study the process they go through to troubleshoot the circuit, and then I'll compare the things they do with what we know about how experts troubleshoot well so that we can identify ways to help them improve. The goal is to use that knowledge to design dedicated troubleshooting exercises for these students and then integrate those exercises into existing engineering classes across majors. This work should not only help them become more competent engineers who actually have the skills to solve real-world problems, but it should also, hopefully, reduce the number of students who feel like that every time they have to do a lab experiment or a project and they can't get it to work. And who knows, maybe we'll save the lives of a few extra printers in the long run. Thank you.
Thank you, Chris. You know, the graduate school is amazing because they printed this out for me. I was going to print it out, but my printer wasn't working, and I couldn't figure out what was wrong with it. I feel like this is a ripe area for entrepreneurs to make printers that don't break all the time. So entrepreneurs in the audience, major opportunity. All right, our next presenter is Luani Lando from the Department of Biological Sciences. The presentation is titled "How Our Diet Impacts Our DNA, a Potato Story." Luani is from Brazil and impressively speaks 4 languages. But this one will be in English today.
Yes.
All right, Luani. Ready, set, pitch.
What is one thing we always find in American plates? Potatoes. We all love them, right? But we haven't been eating them forever. Actually, our ancestors only started eating them 500 years ago. Unless you're Peruvian. If you're Peruvian, your ancestors, specifically Peruvians that live high up in the Andean mountains, were actually the first to plant and eat potatoes 10,000 years ago. And that has been a really important part of their diet. Now, potatoes are made of starch, and starch can be a little bit hard to digest. So our body relies on this group of genes called amylases that are responsible for breaking down the starch present in potatoes. In my lab, we're interested in understanding how human genes change over time. And one thing I didn't tell you is that the amylase genes can vary from person to person. So that means that I might have 2 amylase genes, but you might have even up to 13. So we asked the question, after thousands of years of eating potatoes, have the Peruvian amylase genes changed? And to answer that, I sequenced the DNA of 85 Peruvian individuals, and I counted them. I counted how many amylase genes they had. And I found that, on average, Peruvians individuals have 10 amylase genes. Now, that was significantly more than any other population in the world, even as compared to the Maya population that you can see here in red, and lives really close by but does not eat potatoes. They have almost half the number of amylase genes as compared to Peruvians. Now, this is a really cool story, but why does it matter? Well, for a long time, we thought our DNA defined who we were. It was our destiny. But with my research, we found one example in which a cultural change, such as eating potatoes every day, after thousands of years and multiple generations, led to changes in genes of an entire population. So yes, your genes define some of your traits, but also our culture might shape our genes. And maybe what you have in your plate today will help define who we are as a species in the future. Thank you.
All right, judges, give you a minute. All right, our next and penultimate presenter is Chathra Pereira from the Department of Biological Sciences. The presentation title is Pausing by Tangling, How RNA Knots Tell Genes to Stop and Go. Chathra has a very fun fact. My friends and I once got lost in the mountains of Sri Lanka until villagers found us. They were calm, we were not. Guess who led the team? Also, another good one, I'm sorry. I once voiced an international noodle commercial. I gotta find that.
And nobody believed it was me.
Yeah, so that's...
And nobody did.
Yeah, I kind of, having a hard time believing that. Okay, all right, I believe you. All right, Chathra. Ready, set, pitch.
How many of you have ever taken antibiotics? Almost all of us. And how many of you expect them to work? But for some people, they just don't. They lose even life, not to injury, but to an infection untreatable. This is antibiotic resistance, a crisis affecting millions every year. And we must fight this. For that, we need to understand bacterial control systems down to the smallest detail. And that is exactly what I do. Now imagine this room is a cell and you're inside. Down long roads, tiny vehicles are moving. And as they move, they spin out a long thread called RNA. Like any other vehicle, they pause at molecular red lights Sometimes they pause even longer. Why? That RNA gets stuck inside as a knot. And this knot is not a mistake. That is how they adjust timing to make better decisions. Every living cell depends on these timed pauses, even dangerous bacteria. The better we understand, the better we change them, right? And here's the puzzle. We know pausing happens, but we don't fully understand why some RNA knots hold the pause longer than others. Right now, scientists study these knots, but one at a time. It is like judging buffalo's weather from one summer photo. And that limits what we understand. And I built a smarter way. Instead of one, my tool studies thousands of knots. Last time, I tested over 65,000 different versions of the same knot in one time. Somebody else would have repeated the test 65,000 times. And that way, we can see how the knot forms and how it slows down the vehicle. And my tool allows scientists to study urgent biological problems, including antibiotic resistance, but not just one case at a time. Of course, I don't make antibiotics. I made a powerful tool to understand principles, so no more guessing. And also, you've seen how apps predict traffic with lots of prior rides. Like that, as I collect more and more data, I can even predict pausing with computers, even without lab experiments. So next time you're waiting at a traffic light, remember, pausing is built-in control. For the first time, we can explain it and predict it, and with that, we are going to change the way how we fight deadly infections. Thank you.
You know, I can say as a previous competitor in the 3-minute thesis, the lead up to this moment for the competitors is like you're in the car, you're reciting your presentation, you're in the shower, you're reciting your presentation, and now you've done it and you can release it from your brain, and that's got to be the best feeling ever. There's a lot of smiles over in that corner. But there's one person who cannot yet do this. Our final presenter, Lakshmi Ganesh Shankar. Sorry, Lakshmi, 3 minutes away. From the Department of Mechanical and Aerospace Engineering, her presentation is Smokeless Fire. She grew up in India, or born in India, I should say, and it says here that she likes planning trips and finding off-the-beaten-path locations to visit, and also likes learning about quirky events happening around the world. I'm wondering if you ever combine those and travel to quirky events.
Someday.
Sometimes. Okay, Lakshmi. Ready, set, pitch.
What's the first thing that comes to your mind when you look at this picture? How I wish it was me sitting in front of the fireplace enjoying the warmth on a cold winter night. It's not just the warmth. It's proven that looking at these beautiful dancing flames can help lower your blood pressure and your heart rate. While this picture is beautiful inside the house, there is a dark side to burning wood. Yes, the smoke that goes out through your chimneys. The smoke that basically represents 30 to 50% of the work you put into cutting those logs. The smoke that enters into your bloodstream, your lungs, can cause long-lasting effects like asthma, heart attack, or even death. So it's not surprising that burning wood and the smoke from that is the cause for pollution in winter, a very major cause. And it can cause 8,600 premature deaths every year in this country. Now you must be wondering, we've all been burning wood for such a long time. How come this problem of smoke has not been resolved? This is where it gets tricky. Smoke is like a double-edged sword. On one end, when it is produced inside the fireplace or close to the wood stove, it helps radiate heat. You feel warmer, faster. But when it goes out through the chimney, it causes pollution. At present, we are at a crossroads for home heating. The electricity prices are skyrocketing. And we have wood right at our backyard. It's reliable, affordable, and all it requires is a 21st century upgrade. And this is where my research comes in. You know how Iron Man uses Jarvis, explores multiple scenarios, finds the best option to move forward? I have built a Jarvis, but for the wood stove. to understand complex interactions between chemistry, heat transfer, materials, all that to find the best design with the best materials, the best way to execute burning, so that I can reduce emissions by 50%. I can reduce the hard work that you take to cut the wood by 30%, and make sure you all save $2,000 every year in heating, all while enjoying these beautiful flames, enjoying its warmth, and breathing easy. Thank you.
All right, congratulations, presenters. You all made it through. I made it up the stairs 10 times without tripping and embarrassing myself, so I'm happy about that. But those were incredible presentations. I want to take a moment to once again congratulate all 10 of you on such an incredible job. All right, at this time, I'm going to invite our judges to step out of the room to deliberate about the presentations. And all the finalists, please head out behind them for a group photo in the hallway. Everyone else, please remain seated. Remember, you are all judges here. So it's now time for you to vote for the finalists you feel did the best job communicating their research. I believe we're going to have a QR code. We do. So if you have a phone, you can get in there, cast your vote, one vote per person. And to keep in the theme of the 3-minute thesis, we are going to time you. So you have 3 minutes to vote. I will ask our official time keeper to begin the timer. Ready, set, vote. There we go. All right, so now that the voting is complete, we have a brief interlude before the award presentations. But for your entertainment, since this is the 10th anniversary, while the judging panel deliberates, it's my pleasure to introduce a video highlighting the 3MT competition over the years.
It's so exciting for this to be our 10th year. When we started the 3-minute thesis competition back in 2016, we weren't sure what the campus response would be. That first event, it was so gratifying to see a positive response from the students, from the faculty, and from campus leadership.
I was fortunate enough to go to Ontario and witness the Ontario 3-minute thesis competition. Seeing a 3-minute thesis competition at another location really inspired me to think about how we might be able to create a similar engagement here that was lively and really got the whole campus involved.
I did go to that first offering, and I remember being blown away.
3-minute thesis is not a competition that's just for students in the bench sciences, not just for engineering students or students in management, students who are really focused on entrepreneurship. It is for all students. So we have participants from the humanities, from the arts, from theater, from public health, from medicine, across every discipline you can imagine.
My hope with my research is to measure subdermally or within the finger to use that as a biometric.
What if you could switch cancer off?
Our energy harvester is going to replace the battery inside the pacemaker. It's going to get the vibration from the heart and convert it to the electricity needed for the pacemaker.
And I came back after that and said, next year, we have got to have our students in this program. I saw this as a skill set we did not teach in a traditional classroom.
The biggest benefit I see for many students is that it builds their confidence. A lot of times my students know a lot of things, very technical things, but then they can't really explain it, and I think it's a lifetime lesson.
We're trying to train students not just to be experts in their own field, but to understand what is the context of their work in the broader societal impact. It is not how well your PowerPoint is. It is not simply your style of speaking or whatever. I said what people do recognize is the clarity of thought that comes out of whatever language you speak, whatever topic you work on.
I gave a presentation about celebrating the first, which was focused on first-generation college students. What can we learn from those who have successfully navigated higher education and done really well? What can we learn from them to make our schools and our colleges a better place for incoming students? It is empowering to really look at your work and summarize very quickly how impactful it is and the difference your work is going to make.
So when my students go to this competition, as a faculty member, as a mentor, it really makes me so proud that they can tell non-specialists, the taxpayer who supports our fund, the importance of what we're doing. So we don't have a lot of opportunities like this where they can really talk in a simple way, an understandable way, the relevance and the importance of what they're doing in the lab.
How do you take something that you've worked on for years and simplify it into 3 minutes in front of a crowd of people who aren't experts? So I've been doing a stage present training for years now, and it really has been transformational in seeing how our incredibly intelligent PhD students take their ideas, not just say it, but really sell it and get to tell their story.
With the help of the mentors, which constantly mentor us for the 3MT competition, I constantly molded my pitch, and eventually I feel the reception was extremely good.
Finalists have graduated from UB. Some of them come back and participate as judges. They have come and helped us out in training the next round of 3MT finalists in our workshops and sharing their own experience about why it's been valuable to them. It is fantastic to see them, and they're always delighted to be able to engage with our current graduate students and encourage them to get up there and try it.
So I didn't want to just come in and give you a highlight of 3 minutes worth of stuff that I've learned in the last 5 years, 7 years, whatever. I wanted to create a story so that there was some sort of narrative that pulled people through, that got people engaged and interested, so that maybe they'd be able to remember it after I was done talking. But then I also just have been able to continue to use the type of structure that I put together for 3MT when I explain my work to other people.
It's about sharing the hard work that you've done throughout your PhD career.
The smart home is not yet here. But through research like mine, we're taking huge strides.
It's not just about sitting behind a computer and working all day. It's also about sharing that and making people excited about the potential of your work.
3MT for me is one of the most succinct and one of the most to-the-point ways to describe what I'm researching, what is the point of my research.
Whether it's home or abroad, Muslim women are constantly misinterpreted and misrepresented.
It is one of the ways to describe and tell people that my research matters.
When I was ready to start the competition here at UB, the first thing I did was reach out to colleagues in what was then called Blackstone Launchpad. Today it's called the CoLab, because they are experts in teaching individuals how to have entrepreneurial and intrapreneurial skills.
Entrepreneurship is really conveying to someone your idea and the problem that you've identified and the solution that you've identified.
You're constantly in the elevator giving a pitch. You're constantly talking about your projects. You're always going in front of that person and saying, hey, this is why my technology, my science, my research is valid and should deserve more X, more funding, more resources.
We're teaching them using the skills of entrepreneurship how to convey what they've learned in a way that folks can understand it in a more digestible manner that doesn't overwhelm you with the information. We kind of decided that wouldn't it be wonderful for us to partner to bring our, what I call secret sauce, right? We do the training of students on how to present their ideas, how to carry themselves in front of an audience, in front of a camera.
What if there was another way to assess concussion recovery? That's where saliva comes in. Our lab currently takes saliva samples from concussed athletes, and using bench work, which are laboratory experiments, we assess that saliva.
It's always wonderful to have different entities on campus collaborate and partner on an initiative, because it really provides everyone to bring their best A game, their best content to the table.
In some ways, the most unique 3MT competition we had was in March 2020.
People in our campus community were starting to talk about whether we should consider switching things to remote.
We knew immediately we wanted to keep the competition because the students had worked so hard and we didn't want to deprive the students of the experience.
So the day before the competition, we sent an announcement to the campus community and we canceled live audience participation. We asked the judges to stay home. We told everyone that we would only have the minimal number of people in the theater.
The energy wasn't there, the nervousness wasn't there, there was a lot of uncertainty, but we wanted to make sure to host the competition for the students. 2021, we held the event fully remote. At that point, we had enough experience across the campus to be able to pull that off.
A different level of pressure when you're in front of your laptop than when you're in front of a stage full of people. But it really was incredible to see and still get to see them celebrate and get to share their research.
I think watching this program evolve over the last decade has been incredible. And what's really amazing is when we come to the competition, entire labs are coming to cheer them on. It's super fun to see how much support is rallied around the finalists from their schools and their campus community.
I don't remember anybody being concerned about winning. I remember everybody focusing on the whole competition going well, making sure everyone was comfortable and cheering each other on. There was so much clapping and excitement and pointing out what everyone was doing well, and that's what the culture of it was. And that's a beautiful representation of what academia could be.
We've all been through this really difficult PhD process. So being able to share those ideas with your peers, that is something that stood out to me. And it's funny because right now I still have a lot of them on LinkedIn, and seeing their career trajectory and seeing how successful their careers have been so far, it's just a testament to what 3MT can do for us as students and researchers.
I so enjoy hearing the presentations and seeing the amazing work that our students do, and I so enjoy the energy of the audience. It is really gratifying to have that kind of celebration of doctoral education here at UB.
I'm very proud of our own students that have done it in our school, but I'm proud of all the students that have taken on this journey and gotten those skill sets.
It's an academic parental pride. I think that's what we thrive on. But I think the ones that I feel more excited about is students who had shown reservations and who have transformed in going from their concerns or reservations about their work.
It was really a proud moment for me. I wanted her to have my support. All my students were there. I wanted her to know that whether or not she wins, I am there and I'm proud.
As I look back, I can't believe it's a decade, right? That's unbelievable. But I think it's just a testament to the incredible research and community we have here.
Over the last 10 years, one of the things that's been incredibly gratifying is just how participation has grown and how interest in the competition has grown, so that we've gone from an event that we weren't sure we would do again or how often to an event that I think the campus now expects every year.
I would say I use the 3MT skills both in a pitch setting and both in an everyday life as well.
I wouldn't be where I am today without that experience, and I don't take that lightly.
We hope that people take away from this some inspiration and maybe even cross-collaboration in future initiatives, because they're getting ideas and thinking about their own work from a different academic perspective.
If you're interested in presenting your research and you don't want to participate in the 3-minute thesis competition, you can participate in the Art of Research. The competition is open to master's, doctoral students, and postdoctoral scholars. The deadline for participation is coming up later this month, so check out our website for more information. Art of Research is a competition where we ask graduate students, master's students, PhD students, and also postdoctoral scholars to represent their research in one image that shows the meaning and the creativity of their research.
Research is primarily a practical pursuit, but even in collection of data, patterns arise, and there is beauty in that.
This is a great event for students, but it's also a great way for the community to learn about what happens at the University of Buffalo.
My picture is showing two different types of cells in the peripheral nervous system and how they are communicating between each other.
I wanted to show that data visualization that I submitted my work in can be fun, can be exciting, and can be magical.
And from my work specifically, I hope they take away some sense of geological scale, especially the time scales that geology operates on.
I study what past climate was like in Western New York using lake sediment cores. So I really wanted to take a step back and try to capture an image that showed the kind of fieldwork that we do and the teamwork that's involved.
So this image shows the disparity between incidence rate between low and high income countries. And cervical cancer is a preventable cancer, and it seems that in low and middle income countries, cervical cancer prevention isn't an option.
The image I chose to submit for this competition is one of a permeability map of a sample of dome lava that is speckled with enclaves. It shows how a through-going fracture through the rock displays different data of permeability.
I'm trying to detect the amount of PFAS, which is like the forever chemicals in human blood. So when people would see this, they will see, oh, there's actually something in my body. It's actually like there.
My presentation today looks at a fascinating creature called the axolotl, who actually has a regenerative heart. So trying to communicate to people that don't know those words in a way that can engage them and try to make them understand the research you're doing.
I love this event because when you're a graduate student, you're in the lab or the library all the time and you're working so hard on your projects. It's so much fun to see the students out explaining their research and really showing us what they enjoy about their research.
We focus on bringing attention to the details that we matter. In creating art, it would be transmitting emotion. In creating science, it'd be transmitting an understanding.
Sometimes just going along the way, you find that you created something beautiful.
What an amazing video, and truly, this is such a great celebration of all of the years that this event has been happening. I want to also just celebrate the graduate school and the CoLab for all of the great work that you've put into this. I know your teams work really, really hard, and since I competed in 2020, there's been a dramatic expansion of the resources and even the size of the prizes and just the trainings available and the artwork out there. I mean, all of that stuff is awesome, so let's applaud them. They deserve it. So I'm being told that the award winners are still being tabulated, so I think it'll just be another minute or two. We don't have any more footage to play, but if you just want to hang tight for a minute, we should have the awards out soon. Okay, I'm getting in my earpiece here that we may have the final results. I don't have an earpiece, but I got a thumbs up. Okay, well then, at this time, I would like to welcome Graham Hamill, Senior Vice Provost for Faculty Affairs and Dean of the Graduate School, back to the stage to begin the award presentations.
Thanks, Ben, and here we are. Before we start, I was told to let people know that if you want to participate in the Art of Research for this year, which I hope that many of you do, that submissions are due this Monday, which is the, thank you, and they are due by 11:59 p.m. that day. So you have the entire day right before midnight, like Cinderella. And I would encourage you, it's a really fun event, and if you are a faculty member or a staff member, I would also encourage you to go to the event. It really is, it is a lot of fun. So this now is the moment that everybody's been waiting for. I want to congratulate today's winners. I'm going to call the name of the third award winner, the second award winner, the first award winner, and then I'm going to conclude with the People's Choice winner. When I call your name, please come to the stage to receive your giant check, and then remain on stage. I think we're going to take a photo up here and then stay on stage. Okay. So the third place winner is Gavin Rafleur, Counselor, GPT. Second place winner, Yayu Yamamoto, Who Owns Teachers Learning? First place winner, Chris Romeo, The Trouble with Troubleshooting. And finally, the People's Choice Award, Chathura Pereira, Pausing by Tangling. So thank you to our judges, IMS, and our MC, and to everybody here, to our audience. After the live stream ends, you're all invited to a reception out these doors. Thank you very much, and congratulations to everyone who participated.